Computing Center in Nebraska. We have two locations, one in Lincoln and one in Omaha. That's why there's two pictures on the front. And the idea here was to do a shameless recruiting pitch to your talented students, none of whom are here, so you get to not see and endure that. If any of you know any students that are looking for a grad school, please send them our way if you would. We would love to have them. So the idea here is submit locally and compute globally. So let me ask the audience, what's your idea of submit locally? What does that mean to you?
Q-sub, I guess.
Yeah, so you're thinking of a command line interface and you Q-sub something into it. All right. You gentlemen similar, or?
Maybe not as specific on a particular command, but maybe just if we had a site like Enron and we had some job submission implementation, that maybe our people would submit it through there.
Right.
And it would go somewhere and run.
Okay. Right. Okay. Good. What do you think scientists on your campuses would think of when they think of the phrase "submit locally"?
If they're environmental scientists.
Yeah. Fair enough. There's a broad spectrum of scientists on our respective campuses.
They probably think you were talking about planting a tree, I guess.
Yeah.
Get rid of the word scientist.
Yeah. No, I mean, in terms of submit computational or digital information jobs locally, what would they be thinking of?
Maybe they're just their lab.
Yeah, they're probably thinking of like their laptops or their local desktop. Okay, so we'll see how we did. I was guessing likely answers. I want access from a familiar platform like my laptop or a local desktop. I want access that's simple and low latency. So if I'm going to submit a job out to some supercomputer or to what we might refer to as the cloud, I don't want to have to wait for 10 minutes for initialization steps and uploading my files and things. I want to push go and know that job is submitted. At least that's the feedback we often get. And much as one of you said, I want to run on local resources first. That sort of feels responsible, and it kind of makes sense. If we're going to have local resources, we should use them. So I would like to submit it, say, on my laptop, and then as needed, it would go out to somewhere on my campus or even in my department. And then maybe I have close friends. So, we send jobs to Purdue all the time, or I send jobs to Wisconsin. Through mechanisms other than more formal arrangements, we just have that tightly linked in Nebraska. And then finally, I want to overflow to national infrastructure, which is actually what topic I was supposed to cover today, and I hopefully will get to that. But the point would be how to get to national infrastructure and why would we care about them. Okay. And at the end of the day, we want these things to be convenient so that it actually enhances our computational productivity and our scientific workflows, as opposed to imposing a new set of rules and syntax and bottlenecks that we would prefer to avoid. Okay, so same song, second verse. I normally teach at exactly this time, and that's why you're all being subjected to these quizzes. So I'm normally teaching cluster and grid computing right now in Lincoln, Nebraska. And so, compute globally. What comes to your mind when you hear the phrase compute globally?
Expensive?
So it sounds expensive. Yeah, okay.
Expensive and heartache trying to get people to understand that different systems have different characteristics.
Mm-hmm. Right. So there's going to be heterogeneity, there's going to be these different characteristics, and that's going to lead inevitably to failure and heartache.
That's it, yeah.
Yeah, okay.
Just a bit.
Okay, so I was sleep deprived when I made this slide. The guesses I made were a little more positive. So when I think of compute globally, I think of access, and I should have put probably ready access to national scale resources. And again, we could say cloud. I'm not going to use the word cloud just because I don't know what in the world that means to myself, let alone to other people. It's fine to use it. I'm not opposed to it. And one could make the same argument about computer, but somehow that doesn't bother me to use that word. But I'm not avoiding it because, I mean, we use Amazon, EC2 services, and we use their spot pricing options. We are not anti-cloud. I'm just not sure what even anti-cloud would mean. We have access via high-performance networks. When I think about computing globally, there's no way I can use I think it's probably still in my attic, my old 1200 baud modem to compute in Australia. It's just not going to work. And even if it did work, no one would use that kind of bandwidth anymore. It's just too blamed slow. Okay. And then finally, I would really like, when I think of compute globally and what would make it a positive experience, I'm willing to put a little more skin in the game if I'm going to get access to orders of magnitude more resources. I'm just not willing to have to wait months and have to spend half my day in a user manual or a tutorial to get access. And especially I'm not willing to have to repeat that process every few months when they upgrade and change things on me. Right? Okay, so I want it to be only incrementally more difficult to do this. Okay, so in particular, there's three main resources that are sort of connected to Holland Computing Center, or the Holland Computing Center takes advantage of, and I want to make sure that I mention those explicitly. So one implementation is Open Science Grid. This is sort of a grassroots, although there's major players involved, grid across the country where we do high throughput computing primarily. Some of it's very data intensive, but it is in general not majoring on high performance MPI type codes. It's majoring on high throughput bag of tasks, largely independent codes. One of the more famous ones is the LHC processing. It was mentioned in the last talk. Okay, but the Open Science Grid, we're part of that. One thing I like about the Open Science Grid is we're part of that. We're not just consumers, we're contributors. It's harder to contribute in some of the other infrastructures. Compute globally, Exceed. We're part of Exceed. We have campus champions. We have a student campus champion. We believe in high performance computing, and we do it both locally, and we have a few users on campus that are doing this remotely. As you know, if you have an Exceed machine, you also have fancy artwork. None of our machines in Nebraska have, some ancient nautical animal on the side of it. But that's pretty cool. I had the privilege of meeting some of those folks, and they do great work. I think Kraken is still in service. Did they retire it yet? I think it's still...
Not for a while, I guess.
Yeah, it's still going, right? I mean, they turn over quick at that scale, right? But I'm talking about there, I'm talking about machines 100,000 cores or more, right? And then finally, compute globally. And this was a strange PDF effect when I imported it, and I kind of liked the photonegative thing that happened here. But, Internet 2, and we're familiar with that. I'm aware of, National Lambda Rail, not opposed to it by any means, but Nebraska has closer ties to Internet 2, so that's what I think of when I think of global. Okay, so submit locally, compute globally. Nice idea. So there's some context here. I've mentioned it along the way. I'm representing the Holland Computing Center, where we have a university-wide mission, meaning not just University of Nebraska-Lincoln, but also in Omaha and UNMC. For what it's worth, there's a fourth campus, UNK, and we're starting to get some usage out of those folks as well. And we provide both HPC, or high-performance computing, i.e. NASCAR, and high-throughput computing resources to these different campuses, i.e. UPS or something. So we're moving a lot of things, getting a lot done, but one individual job or package isn't necessarily so huge. So our resources, we have a set of both high performance and high throughput resources. Our largest high throughput computing resource is with the petabytes of storage, the vast majority of which was purchased through Dell's global program for the LHC experiments, and then the high performance machine, the main high performance machine right now is also a Dell machine located in Omaha, known as Tusker, which is a mammoth-like creature. It wasn't a clever alliteration between Tux and Husker. Okay, and then finally, although if you want to believe that, that's fine. If you think it's clever, then yeah, I thought of that. And then finally, what we do with HPC, if you run out of resources there, you submit to Exceed. We candidly, in this room, have a lot of trouble getting users to do that. Most of the users that do that just bypass us because they're entrepreneurial enough to realize 100,000 is a lot more than 10,000, and they just go for it. Or maybe that means we're doing a good job locally. But anyway, high throughput computing, we're quite good at moving things out globally, and so I'll talk about that a lot more. Okay? So here's the idea. I'm sitting here maybe in this little circle as a user, and I want to submit my job, and it should just run out and run on Rolla's campus somewhere. Why should it go to Lincoln or Champaign-Urbana or wherever? Why not just run locally? Can't be more expensive unless I've implemented it badly here. And then finally, maybe, it's not good enough, and so it needs to go out to the broader campus. Okay, you may not have centralized resources, and so it's going to go out from chemistry to geology or to earth and atmospheric sciences and use cycles there. In our case, it roams out from Lincoln over to Omaha primarily. Okay? And then finally, it's going to go out to what at least used to be called the grid. Now you might call it the cloud, whatever you want. It goes off campus. And we do this, we implement this technically, and because I believe most everyone in the group here is quite technical, there's no newbies anyway. So here's our user, and they submit, for instance, one scenario is we submit into a Condor cluster that's local through a Condor scheduler. Okay? And then we'll just run out to this Condor cluster, and everyone's happy and it gets done. The problem is it's not very large. So we have a large, it used to be PBS cluster, I'm sorry, this is now a Slurm cluster. The point is it doesn't matter. Just run Condor inside of that scheduler. Hope that made sense that quickly. For this group, it probably did. So those are Condor worker nodes, are the jobs submitted to the Slurm scheduler. Okay, and you need a little piece of software to do that. We call it a campus grid factory, but that's for another talk when we, are not already late. So anyway, the point is, you overlay this Condor infrastructure onto, say, Slurm and other things. Oops. Oh, I went backwards, not forwards. Okay, and then now I can run my high throughput computing there. And it can coexist with the high-performance jobs. Okay? Well, maybe that gets full, and it does. So then it's going to run out here to some interface or out campus, either directly through flocking is a mechanism Condor uses, or it's going to go out to an OSG, international interface. We do both successfully. And it really does work. This is last calendar year, we have, or 2012, last completed calendar year. And you can see here's where Tusker came online. We had this huge ramp up. And then we pretty much, serve out about 10 million CPU hours per month at this point through Holland. This bigger bar up here is the LHC CMS experiment. This is an eye chart at the bottom, so I just tell you. And they of course provide hardware, the project does, which is why they get the biggest bar. But there's other unfortunately is everybody that's small users, but in some sense that's good. That means there's a lot of users that are just able to use a fair amount, and it lumps together. They're not in the top 25. So that's all of the non-top 25 users. But then we've got a nanoscientist doing traditional HPC, another local grid usage, another physicist, and so on through this top list. Several physicists, an earth and atmospheric scientist, folks from Wisconsin, bioinformatics, actual computer scientists using computers, and so on. Oh, and I gotta get more careful with my clicker. Okay, there we go. So it works. Okay, so the other thing we do, and I apologize for scattering these slides about, is that we use what's called a gliding WMS submit host. Who cares? The point of this is a way to overlay Condor, if you will, on remote jobs, remote sites as well. So now those look like Condor worker nodes to my local scheduler. Okay, and it just becomes this amorphous, amoebic blob that goes all over the place and reserves a slot. Works well for us. Okay, that's an open science grid mechanism, and we've done that for local folks doing graph theory, protein active site comparisons, other bioinformatics algorithms, and some data processing through a group using radar to chase down storms. We offer about 4 million CPU hours per year, and you probably say, well, but Dave, you're doing 10,000 a month, so who cares? The point is those come in extremely large bursts. So that gives us this capability. I mean, those are probably offered over the course of less than a weekend kind of thing total. On a given weekend, I can get hundreds of thousands of hours this way very quickly. Okay, so that was just to refresh our minds here, but we won't need to spend much time on that. But finally, I want to emphasize more, not finally, but next I want to emphasize more the idea of how am I going to make this be truly a submit locally kind of thing. Well, now we've created a little interface called Bosco in a barbecue areas. This is not Tabasco, this is Bosco. And what you do is you have now a little Condor submit D on your own laptop. And I just submit jobs into Condor on my laptop. So Condor submit space job. And you can create a little graphical interface where you hit, go gadget Bosco if you want to, but so far we haven't done that. But as an aside, somehow, there's got to be a middle ground between we need to make it not so unnecessarily hard to use these machines and not insulting the intelligence of world-renowned scientists that they're too stupid to use a command line interface. I'll go to my grave refusing to believe that. Okay, they may not want to learn it for some strange reason, and if so, maybe I shouldn't force them to, but certainly they can learn to type QSub as well as I do. So anyway, the point here would be, I have my submit host, and it's under the hood right now, locally, just using secure shell, and just use keys, and you're done, right? And then after it knows the connection to that cluster, now I use a little piece of software from Europe that allows me to overlay Condor on a cluster that's not already a Condor cluster, as we call block. It may be German or something, but don't worry about the acronym. The point is this earlier diagram. So now I've got worker nodes running in my PBS cloud that are answering to my submit host on my laptop. And then this submits the job in there, and it manages this. Okay, so it's kind of cute, but why do that? Because Condor's good at some stuff. It's really tremendously good at some stuff, and we're going to leverage that. Okay, so it's not called HT Condor. They got into a legal battle. It's not called HT Condor, and HT is silent. And I kid you not, that's really what they're having to do, because somebody trademarked the word Condor. Okay. Anyway, it's been around for what, 15 years? Never been an issue until this year. And so we use that to submit the jobs. That gives you all sorts of niceties. It can throttle how many jobs it will throw at your cluster at one time. So it doesn't overwhelm your local cluster if there's too much I/O or what have you. It will allow you to query the job. It gives you statistics. It gives you management capabilities. It lets you move them about and so on. It has some rudimentary file transfer capabilities. And we just use secure shell now. You can use GSI. I won't say you can use Kerberos. In principle, you could. I don't think that's going to be implemented anytime soon. But secure shell, for our cluster is good enough right now. And then we use, this interface to allow us to have this sort of Condor overlay. Right now, the install is literally, young install or just click, because it auto detects your remote cluster OS, and it installs the appropriate Bosco installation, and off you go. Okay, so yeah, you get these niceties that come from Condor that you wouldn't otherwise get. Jobs are transferred back and forth. Your job data comes back to your local computer. No, your local computer does not have to stay on. It just waits for you if it's not on, as long as you have an account on that cluster where you sent it to. Actually, even if you don't, it will. And it doesn't care about the remote OS version. Okay? So to be clear, you do install one component locally, which is really small, and another component remotely, so that they know how to talk to each other. Okay? So there's initial setup per cluster, and then you're done. And then finally, we found that for whatever reason, even though I'm so strongly committed to the idea that world-renowned geniuses can type 8-letter strings, they don't want to many times. And I guess it's time to stop telling them they have to. And so, but they do like to type all sorts of complex things inside of a MATLAB or R or other type of shell-type environment. Right? The bioinformatics folks at UNL, by and large, love R. And they love it not just on September 19th. And if you understood that, I feel bad for you. But anyway, the Bosco is now integrating directly with software projects. So you go into R and you call grid, hide, stuff, arguments, And so you can now grid apply your functions. So if you're running R and you notice, oh, crumb, this section takes forever, I guess I'll go get a coffee and then we'll just get a coffee and then go get it downtown and come back. You can offload that transparently now to your local cluster. Now, it may not get done more quickly, but your laptop isn't, bogged down with it. And if you have parallel implementation, it probably will go faster. And you all in this room understand that plenty well, so we'll move right on. So anyway, if you want to try this, Bosco is easy to remember. It used to mean something. They've kind of abandoned it. Pretty sure the C used to be Condor, and O in one of these was probably Open Science Grid, and who knows what everything else. There's probably Block and other stuff in here. But Bosco is integrated into the HT Condor release now from the University of Wisconsin. Okay. Finally, let me go back to the, so that's high throughput computing, submit locally, compute globally. We like it, our users like it. We're mostly in a happy ecosystem with that. We also have HCC, we have high performance networking. This is 10 gig. We swamp this regularly, moving LHC data around. We have two locations, Lincoln and Omaha, connected at 30 gigabits per second. We got recently it was announced a CCNE award. They put it on the NSF website, so I guess I can say it in public now, that will allow us to increase this to 100 gigabits per second to I2. I don't know about a time frame on that, but I presume less than a year to get to that speed. Okay. And then finally, we do high performance computing on our campus as well. Here's an example, one of our most prolific groups using high performance computing, albeit not in terms of core count necessarily per job, but overall, they're all tightly coupled codes, is Xiaozheng in chemistry, and they're using your normal HPC stack, and they find things like 17 atom gold clusters, which are important in in terms of catalysis, and it seems really counterintuitive, right, that you'd have a prime number gold cluster that's energetically stable. But these things that are kind of cool, not just because they're fun to find, you can see the 17 etched at the top here, but also because it turns out they find these things subsequently then experimentally. He's collaborating with other experimentalists that verify these aren't just science fiction, although even if they were, it'd be kind of cool. But they're not an artifact of the calculation is what I mean. They seem to be physically relevant results. They are. And this is another really cool thing they've done where they've created an artificial membrane pore, completely synthetic, and so they calculated what it should be, what the diameter should be, and now they're starting to look into biological applications of these things. Okay, but you just go in the lab and they make these things. Okay, so I can say more, but I think we're at the top of the hour, and I'm not sure, but I'm getting nodding like, yes, please wrap it up. So I will. Let me thank the administration, the Academy, NSF, DOE, EPSCoR, OSG, the Holland Foundation. These are the physicists I work closely with who have brought about a lot of this revolution in high-throughput computing. Ken Bloom and Aaron Dominguez. Xiaozheng and his HPC work has been there for years and continues to do interesting things. And here's a lot of the people that do the real work, either staff or students or other collaborators. Okay, I'm happy to take questions or happy to point out that in some crazy Gallup poll, Lincoln was rated the #1 happiest city, evidently in the 5-mile radius, and I don't know what
You don't know what
area. Yeah, go ahead. Define happy. However you define happy, evidently for this survey, it has to mean it's largest in Lincoln. That obviously meant they won that week in football. They're not happy on Sunday when they don't win. And we do have a new arena, so come visit, stop by, attend a concert, and we'll be happy to entertain you in Lincoln. Thanks for your attention.